Hello everybody, myself Parag, and today I'll be discussing the applications of context-free grammar in speech recognition. Context-free grammar has a lot of uses, for example, natural language processing, understanding a string. But today we'll be focusing on a particular aspect of it known as speech recognition. So without further ado, let's start. So before we actually know what is speech recognition and how is context-free grammar applicable in speech recognition, first step is knowing what is actually context-free grammar. So we'll move on to that. Context-free grammar is a type of formal grammar that is used in computer science, linguistics, and artificial intelligence. It comprises a set of production rules that describes all possible string in a given language. Now what does this mean? What are production rules? For example, S goes to a small a, capital A, and B, slash, it terminates on some symbol, for example, A. Now, S can make strings that start with small a, or it can go to the other production A and B. Then again, A and B can have their other production. For example, A can have a production such as A goes to small b, B slash A. Over here, A can produce strings or letters such as B and then terminate on A. Similarly, B can have its production, for example, B, A, or whatever terminal symbol you want to have. This is how the productions of a context-free grammar work. These rules are used to break down sentences into smaller parts, making them easier to analyze and interpret. CFG is essential in the field of compiler design and natural language processing. Using these rules of CFG, what we'll do is we'll derive a particular string. For example, A, B, 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 B. Now, these, this one string can be derived by the three production rules that I just told you a few seconds ago. Moving on to speech recognition. What is speech recognition? Speech recognition is a technology that converts spoken language into written text. It captures involving and digitizing sound waves, converting them into basic language unit or phonemes, and then using these algorithms to convert these phonemes into written text. Used in a variety of applications including voice-enabled text messaging and voice command, transcription services, and assistive technology for the disabled. Major tech companies like Google, Amazon, and Apple utilize speech recognition technology in their products like Alexa, Siri, Cortana, etc. I think whatever understanding about speech recognition you should have is written into the slide, but more about speech recognition is basically how a computer understand what we are trying to say. It's speech recognition. A practical example in our day-to-day life about this would be anything like Alexa, Siri, Cortana, etc. Simplifying speech recognition can be seen when we are conversating human to human. For example, I am saying something and the human in front of me is understanding what I am trying to say. Now, from a very early age, we know that what words mean and how do they work. Or if I am saying, how are you? Then basically I know how to respond because back of my mind, I know what does that actually mean. Similarly, what we are trying to do is to make computer understand what is speech recognition or what we are trying to say. We'll use CFGs, we'll convert our digital sound waves into text, then feed it to the computer, and then the computer will understand what we are trying to say. This was the basic of speech recognition. So what is the role of CFG in speech recognition? Context-free grammar play a crucial role in speech recognition systems by providing a structured framework for representing the grammatical patterns of human language. They help the speech recognizer to narrow down the search space of possible word sequence and improve the accuracy of recognition. In speech recognition, CFGs are used to define the set of valid sentences or phrases that the system can expect to encounter. This allows the system to focus on processing the input speech signal into a more efficient and targeted manner, significantly reducing the computational load. Now, what does this actually mean? In layman language, what we can say is that whenever you are asking the computer to do some command, for example, call your friend has some letters which we can think of CALL call MYFRIEND. Now what we'll do is we'll feed the computer some rules of CFG as discussed in the previous slides. What computer will do is computer will break down whatever we are saying according to these rules and interpret the sentence. In this case, we have call my friend. This is how a computer will recognize what we are trying to say. Whatever we are saying will be divided into a set of strings. In this case, we have three strings, call my friend. This is how the computer will know what it has to do or what the human is trying to say. What are the advantages of CFG in things like speech recognition? Why should we use CFG itself? Why not anything else? It is because CFG has better expressiveness. CFGs capture a wide range of grammatical structures, including complex sentences with embedded clauses and recursive patterns. Whatever you say, whatever letters you want to say, that can be found by the rules that we are given to the computer. Flexibility. CFGs can be easily modified and extended to adapt different domains and languages. Whatever rules you might want to fit to the computer can be customized by you. That is how it is more flexible than other sort of grammars. Context free grammar, it is also efficient. Context free grammar based parsing algorithms can be implemented efficiently, making them suitable for real time speech recognition applications. These are the few of the advantages that context free grammar has over other grammars, and why we use CFG in speech recognition. So what are main applications of CFG in speech recognition, or what are the basic steps that CFG will use to for speech recognition? Syntactic analysis. CFGs help in structurizing and analyzing sentences to improve the accuracy of speech to text conversion. Command and control system. CFGs are used in defining a set of commands that a voice control system can understand and react to it. Semantic analysis. CFGs help in understanding the meaning of sentences, not just transcribing them. Language learning tools. CFGs can also be used to create exercises in language learning apps, helping users learning the grammar of new language. The fourth point in this is the most important one and unique than other languages. You can even create questions with CFG. Whatever you will say or whatever you want to give input will be recognized by the grammar and will get as our output in the best form. So now we'll discuss the four main pillars of context-free grammar in speech recognition. First of them being syntactic analysis. Syntactic analysis, also known as parsing, is the process of analyzing the grammatical structure of a sentence. CFGs are widely used in syntactic analysis because they provide a formal and expressive way to represent the rules of grammar. By applying CFG rules, the parser can identify the syntactic constituents of the sentence, such as the noun phrase, verb phrase, and prepositional phrase. This information can be used for various purposes, such as machine translation. Identify the syntactic structure of a sentence is crucial for accurate machine translation. Natural language understanding the grammatical structure of a sentence is essential for comprehending its meaning. Grammatical check. CFGs can be used to check for grammatical errors in the text. So what does this mean? Whatever sentence will derive must have a grammar. All the sentences in this world that we are speaking have some sort of grammatical rules bind to it. Whatever we are saying to the system must be logical. We cannot speak something which is illogical. System will realize that but will not know what to do further. So to understand that the sentence has logic, the syntactic analysis comes into play. Syntactic analysis will know what are the verb, phrases, nouns in the sentences. For example, Parag is explaining a PPT. Parag is the subject over here, is explaining is the verb, and PPT is the thing. So this will be recognized by the syntactic analysis, and then the system will know that whatever further proceeding it has to do. This is how syntactic analysis will work. Moving on to command and control system. In command and control system, CFGs are used to define the valid set of commands that the system can recognize. This helps to ensure that only valid commands are executed, preventing errors and unauthorized action. CFGs can also be used to provide context for commands, making it easier for the system to interpret and execute them correctly. For example, a CFG could be used to define a command structure for controlling a robot. As told in the previous slide, whatever you feed to the system or whatever say to the system must be logical. You cannot speak whatever comes to your mind. That won't help the system understand what you are trying to say. Now, once we have given the speech, what further proceeding it has to do will be defined by control and command system. For example, if I'll say, hey Google, please navigate me to a bakery. What Google will do is, using syntactic analysis, it will analyze the sentence. Then that sentence will go to the command and control systems. The command and system control system will interpret what you have to do. In this case, setting the navigation map from VIT Chennai to a bakery shop. Now, this path setting will be done by command and control system. Moving on to the third topic of application of context-free grammar in speech recognition, we have semantic analysis. Semantic analysis deals with the meaning of sentences and words. CFGs can be used to represent semantic relationship between words and phrases. This information can be used for various purposes such as question answering. Identifying the semantic relationship between words and phrases is essential for answering questions accurately. Natural language interference. Understanding the semantic implication of a sentence is crucial for natural language interference tasks. Sentiment analysis. Determining the sentiment or emotional tone of a sentence requires understanding the semantic meaning of words and phrases used. Moving on to the fourth pillar of using context-free grammar to recognize speech, we have language learning tools. CFGs can be used to develop language learning tools that provide interactive and personalized instruction. By incorporating CFGs, these tools can generate grammatically correct sentence. This helps learner to practice constructing sentences in target language, provide feedback on grammatical errors. This helps the learner to identify and correct their mistake, improving their grammatical skills. Adapt to the learner's level. CFGs can be used to create personalized exercises that are tailored to the learner's current proficiency level. So basically, language tools helps to identify what further can be done once the speech has been recognized. This again helps in correcting the grammar of the sentences, provide feedback on whatever the user is asking them. For example, if I'll ask Alexa that how is the day, Alexa will reply me that the day is rainy or the day was sunny. All these sorts of things will be handled by language learning tools. Moving on to the conclusion, as speech recognition technology continues to advance, CFGs will remain an essential tool for developing more accurate, efficient and robust systems. Their ability to capture the complexities of human languages and provide a structured representation of grammatical rules makes them invaluable for tackling the challenges of speech recognition. That's it for the PPT. I hope you understood what are the applications of context-free grammar in speech recognition. I hope I was able to explain you little bit of whatever the topic is. The topic is very advanced, but this was just a small step in understanding what it is. I hope that I was able to tell you that, and that's it for the video. Thank you.